Okay, so the graph of a function y equals f of x is a set of all points whose first coordinate is an element in your domain and whose second coordinate is the associated element of the range, like it's the value you get out when you plug in that number. So when graphing functions, the first thing you should do is find the domain, and some other useful points are the intercepts. And we did this, I think, before. How do you find the x-intercept? What do you do? You set y equal to 0 and solve. We did this in the context of lines, right? But this also can work with other shapes of functions. And to find the y-intercept, you set x equal to 0 and solve. Why can there be more than one x-intercept, but not more than one y-intercept?
Because if there's more than one y-intercept, it's not a function.
Exactly. If there's more than one y-intercept, it'd be something like having a point there and a point there, right? And that's not a function, right? But x-intercepts, you could have a function that has an infinite number of x-intercepts, like the sine or cosine function. Those have an infinite number of x-intercepts, and that's okay. That's still a function. Okay. All right, so find the domain, find the x-intercept, and find the y-intercept for this function. So for the domain, you have to look and see, do you have any places where the denominator could be 0, and do you have a square root? Those are the two things you gotta watch out for. So do you have a denominator?
Yes.
Yes. So the one number you have to exclude is the number that makes that denominator 0. So when does 3x minus 2 equal 0? What?
X equals 2/3.
When 3x equals 2 or x equals 2/3. So for the domain, x cannot equal 2/3, but anything else is okay. What is that as an interval? So negative infinity, 2/3, parenthesis, because you don't include it, right? And then a little union symbol, 2/3 up to infinity. So I'll probably ask you to give your answers for domains in interval notation, which means you have to do that. If it doesn't specify, you can say the first one, but that might be teacher preference. Okay, so for the x-intercept, we plug in 0 for y.
Would
So
it be,
that,
would it be correct to just say negative infinity to infinity and then say with the exception of 2/3?
that's how you say it. As in, like, that interval is how you say what you just said.
Yeah, but with one interval.
Yeah, no, because once you give one interval, you're saying everything in the middle. So really, I mean, it's probably technically correct, but it's never done that way.
It seems like that would be correct because you
Oh my God,
specify-
it's so much writing. Yes, I know, but no, I think it's just not worth worrying about. So if you have 0 equals 4x plus 5 over 3x minus 2, if that was a normal equation and you were solving it, you'd multiply by the 3x minus 2. Does that make sense? You can do the same thing here, like that's okay. And what is 0 times 3x minus 2 going to give you?
4x plus 5.
Well, it's going to give you 0 equals 4x plus 5. Does that make sense? Or then solving for x, negative 5 equals 4x. And what's x going to equal? Negative 5/4. I'd like you to give your intercepts as ordered pairs. So the x coordinate is negative 5/4. What is the y coordinate? 0. Yep, exactly. Okay. And then how about the y-intercept? For that, you plug in x equals 0, right? And you get y equals, what number is your numerator going to be when you plug in 0 for x? 5. What will your denominator be?
-2.
There we go. Okay, and what is that going to be as an ordered pair? 0, negative 5 halves, or negative 2.5, either way. Because you take the equation to find, you plug in x equals 0, we're good? Yeah? I just had to move it up so you could see the problem, but the equation's on your paper, right? Yeah, okay. All right, so same thing here. Ready for the next one? So how is this one a little more complicated? you got squares instead of just single linear things, right? So first, to find the domain, we're going to leave out the number or numbers where x squared minus 25 equals 0. Yep, that's the same thing as x squared equals 25 and x equals plus or minus 5. So you're going to leave those two numbers out. So your domain is x cannot equal those two things. And this one's going to make whole revolt really bad because it's going to be kind of long. So as an interval, it's negative infinity. What's the first number you have to leave out? Negative 5. Parenthesis union. And then you can go from negative 5, not including it, all the way up to 5, right? And then from 5 to infinity. So many symbols. Oh my goodness. I apologize, but it is what it is. Okay. How about the x-intercept? Okay, so you set y to 0, right? And y and f of x are the same thing, right? Okay, so that's 0 equals x squared plus 25 over x squared minus 25, yes? So what happens when you multiply the x squared minus 25 over?
X squared minus 25 equals x squared plus 25.
I think you get 0 equals x squared plus 25.
Oh, yeah, 0, yeah.
Yep, okay, it's okay. And then you get minus 25 equals x squared. And we're talking about real number intercepts, not imaginary ones. So if you get something like this would be x equals plus or minus 5i, right? Yes? So what that means is that there are no x-intercepts. Because the only ones you found were imaginary numbers, and those aren't numbers on your real number line. Okay? So you find imaginary things, it just means they're on that graph, never crosses the x-axis. And that happens with graphs sometimes. Okay, so maybe this thing has a y-intercept. And it will as long as 0 is in the domain of the function. So y-intercept, plug in x equals 0. What do you get for y? What's in the numerator? 25. What's in the denominator? So you get y equals negative 1. So that's the point 0, comma, negative 1. So just FYI, it is possible for graphs not to cross the x-axis. Have you guys ever seen, like my high school students, how this functions? You ever seen this picture? It's the 1 over x function that never crosses the x-axis. Never crosses the y-axis either, actually.
Unless you shift the axis.
Unless you shift it, yep, in which case it isn't 1 over x anymore. Okay. So now we have some pictures of functions, and I want you to find the domain and the range from the picture, and then from the picture find f of 0 and f of 2. And if you have to estimate them, we'll estimate them. So to find the domain is all the x's. And the way to look at that is to look at it and take your pencil vertically and look and see where the graph exists. You go along the x-axis and say, at which x value does my picture start? And at which x value does my picture end? And if there are any gaps, leave them out. So at which x value does your picture start?
Negative 3.
Negative 3. Does it exist at negative 2?
Yes.
Yes, because there is a filled-in circle at one of the spots. And they can't both be filled in because you wouldn't have a function then, right? So it starts at negative 3, and it exists up until 2, right? And you have square brackets because both of those points are included. So the domain is negative 3 to 2. For the range, you do the same thing, but you go along the y-axis and look at all the y-coordinates. And they always go lowest to highest. And Natalie doesn't like it. You gave it a face.
No, I misread one of the dots.
Oh, okay. That
The
happens.
negative 3 was like 9%.
Oh, that's definitely can be confusing. Yep. Okay, so for the range, what is the lowest y value? Negative 3. And you actually hit it, right? Now you go up to negative 2, right? but you don't actually hit that point. Does that make sense? So there you're gonna need a parenthesis. So -3, comma, -2, parenthesis, union. And you have no y's between -2 and -1. When do they start up again?
On -1.
-1, and including that one. And what is the highest y value attained? 3. So for the domain, look along the x-axis, and for the range, look along the y. Yes?
Because the ending point, it's not an ending point, it's in the middle of the line.
This one?
Yeah,
It
the
doesn't-
highest point is in the middle of
The highest point's in the middle, but that's all you're looking at. You're looking at kind of like one-dimensionally. You're looking just to say, okay, well, where is the lowest y, where is the highest y?
So we assume that the line is the whole line.
Yeah, if you have, I think what you're saying is, how do you know that's not an open circle right there? If, it would have to be explicitly given as an open circle for it to be an open circle.
Okay, so if one side of that was like an open circle and the other side was a solid, and they wanted any point in between, like if that -1 was not included.
If that oh, like if this thing was an open circle right there?
Yeah,
Okay,
then how,
then that would become a parenthesis.
but then that same point, how would we know on that line that one was?
How would you know this point?
Yeah. Oh, they would just tell you that.
They would just tell you. Yeah, I mean, it's not, there's, if it's a straight continuous line, you're assuming that it actually hits that point. It's only, so they've got to make it totally obvious that a function doesn't hit a point by either having an asymptote there or by having an open circle displayed. So it will, but if you picture, then it hits the point, then you can assume that, okay, yeah, that picture actually hits that point. Whew, okay, good question. All right, how about f of 0? So that means, what is the y value when x is 0? So look at the picture. When you plug in 0, you get out 2. F of 2, can we find that exactly, or are we going to have to estimate it? Estimate. So let's use a squiggly equals. And what do you say, 2.6-ish, 2.6, 2.7-ish, something like that. Does that make sense? When you plug in 1, 2, the y you get out is right there. And it's it's more than 2.5, but who knows how much more. Okay, next one's the same idea. So first the domain. This one's actually easier than the previous one. What is the leftmost x? -2. And the rightmost x is 2. Now for the range, what is the lowest y value that occurs? -1 happens right down there. And what is the highest y value that occurs? 2. So what those things do is they just give a list of the plausible values for x and the plausible values for y. Nothing outside of them is possible. Oh, because if the picture goes down and appears to hit that line, just assume that it does. I think Tanya was just asking the same question, and she was like, oh my gosh, how will I know? If they don't hit that point, they're going to have to give you an open circle or something there. Okay, does that make sense? Yeah.
Do they use the dotted line?
Dotted lines are something totally different. You're thinking about graphing linear inequalities. Yep. I know what you're thinking of, and it's not this. Yep. Okay. Whew. Random knowledge. F of 0 is equal to...
I said like negative.
I think it's -1.
Or -1, sorry.
It's okay, but it's this point right there, right? How about f of 2? 2. Yep, when you plug in 2, you get out 2, right? Okay. So one thing you're going to deal with a lot in calculus is determining when functions are increasing and decreasing. And it turns out you can use calculus to find these things really easily. What you need to get out of this class is a way to look at a picture and see, okay, this function's increasing here, it's decreasing there, it's constant here. So what does increasing look like as you look at a picture? It goes up. Yep, so a function could be increasing by going up linearly, right? Or it could kind of like meander and go up, right? But, you know, it goes up. Decreasing would be something that goes down, right? Or it could be something that looks like, you know, half of a parabola. What does constant look like?
Straight.
Straight horizontal or straight vertical?
Horizontal.
Horizontal. That's like Iowa. Nothing but constant cornfields.
So what would a parabola be considered?
A parabola is going to be both. So, like, if you have a parabola, you'd say it's decreasing up until that point in the middle. You'd say it's increasing past that point. So you'd have to figure out, like, when does it change from increasing to decreasing? Yes?
What would would it still be negative infinity to positive infinity if it was a vertical?
Oh, if it's a vertical line, it's not a function.
Oh,
Does that make sense why? Because it doesn't match the vertical line test.
yeah.
One vertical line hits it an infinite number of times. So it's a good technical question, though, so it's good to point out. Okay, so let's picture. So here is the other the more technical definition of increasing. So if you have an increasing function on some interval, and your first x is less than your second x. So think about this. You have, this is x1, this is x2, and if you're increasing, you have to have some relationship like this happening, right? So what does that mean about the relationship between their y values? Which way does the alligator eat? Towards x2, exactly, right? You say, okay, well, if the x is less, the first x is less than second x, if my function's increasing, my first y is less than my second y, right? That's what this means. So if you're decreasing, draw a picture. If you're decreasing, does it make sure that your first your first y is bigger than your second y? For it to be going down, that has to happen, right? So if you have one x that's less than another x, what way does the inequality go with their y's? Who does it eat? The x1 or the x2? The x1.
I'm confused about what it's saying with the, and the graph of f is rising whenever. Like,
Oh, yeah. So it's increasing, and it's also saying what it means as a picture. The graph of f is rising whenever this is true, then this is always true. So what they're trying to say, the fact that the graph is rising is that your graph is going up versus the graph is going down. I don't know if I shouldn't have it here. And the graph of f is, and I probably, you know what I did? I didn't fix this. This shouldn't be rising. That should be,
yeah, that's what
that's a great, yeah, that should be sinking. And this should be constant. I think I copy pasted and didn't like change all the things. Okay, how about when you're constant? You have two x values that are different. What's true about their y values? They're the same. Okay. All right, so your notes didn't come out color-coded, and I'm sorry. So f in my picture is the pink function, and g is the blue function. So first, find the values of f of -4 and g of 3. Say that again?
Oh, I couldn't see it. I just couldn't see it.
You just couldn't see it. Okay, f of -4. So this is the y-axis and x-axis can be a bit hard to spot. So I'm just going to like extend them so I can really tell where they are. Okay, so f of -4. That's back 1, 2, 3, 4. And we're going to assume that's filled in because they didn't draw an open circle there. So what is the y value of f at -4? -2. And how about g of 3? So 1, 2, 3, 1, 2, 3, appears to be 4. Okay, for what values of x is f of x equal to g of x? So these functions, saying like the y values of these functions are equal, right? That's going to happen when those functions do what? Cross. So those functions cross here, and they cross here, right? So find the values of x. What is the first x where that happens? X equals -2, and x equals +2, right? Okay. Next one says, estimate the solution of the equation f of x equals -1. So that's also similar to the crossing thing, but here is the line y equals -1. Does that make sense? It's like saying, when is the y value of f equal to -1, right? So you could draw on the line where everything is -1 and look for where does the pink function appear to cross that line. So when does that appear to happen? At what x value? Yep.
What about +4 too? It's like right on.
Let's assume that it actually does. Yep. -3, +4. I mean, if I give you a test question like that, it's going to be far more clear. Does that make sense? Like, I will draw in dots myself if they're not already there.
Wait, where did the 4 come from?
Well, Natalie knows that this line also appears to intersect that graph on the very, very, very far endpoint.
Which is
Right there. Or right here.
Oh, okay.
Right? And that's 1, 2, 3, 4. The x value is 4. The y value is -1. Okay. So on what intervals is f decreasing? 0 to 4, yep. And this is one thing where I'm not sure if your book is actually doing it right. So I would say that this point where it starts decreasing, you would put a parenthesis around. So, and then up until 4, at 4 it's still decreasing. Now, when I was looking at your textbook, I'm pretty sure it put a square bracket around that 0, and what I'm concerned about is the fact that Alex is a computer system and it might do the same thing. Does that make sense? So if you're getting anything funky wrong in Alex, just mess with the parentheses a little bit. But in calculus, I know I would make them put a parenthesis there, because at that point where you turn around, you're neither increasing nor decreasing. There's a slight pause. Does that make sense? Yeah, Tony?
Isn't it 0, 3?
No, because there's 2, 3, 4. It's like, tell me all the x values when the function is going down. And the function goes down from this part to this part, right? So it starts going down when x is 0, and the function just stops at 4, so we don't know what happens past that point. If there would have been an arrow there, you would have said 0 to infinity. Yeah.
Wait, why would you put a bracket around 0? 'Cause it's like on the
Technically, it's a cuspy point. Like at 0, it's neither going up nor going down. So it's like the number 0 is neither positive nor negative. So like so it's kind of the same kind of concept, is that at this point, technically speaking, it's a pause and you're not going up or down at that point. Yeah.
Well, since the graph ends at 4, why
Mhm.
would there still be a bracket? I mean, since it's not doing anything there, technically, it's just
But up,
ending.
yeah, but it ends and decreases to that point. So I think the only ones I know for certain to put parentheses around are the ones that are like changed, like where the changes occur. Okay, how about the domain and range of f? So assuming that we actually have filled in points on the ends, what is the domain? When does this start?
4.
-4. When does it end? -4 to +4, right? How about the range? What is the value of the lowest y? I think, yeah, 0, 1, 2, yep, -2. And then what is the highest y value that happens?
3.
3. Okay, how about domain and range of G? So where does G's picture start? -4. Where does G's picture end? 3. And the lowest y value does happen in the middle. Let's assume it's -1/2. And-
Positive 1/2.
Yes, it is +1/2. Man, those axes are tricky. There's the x-axis. Okay, what is the highest value that G takes on?
4.
So this is 3, this is 4. What's up?
So how come with the 0, we didn't include it, but we included the 4? For the range, 3, sorry, for the range.
For-
That turning point, you're talking about the turning point.
Are we what are you, what are you questioning about, D, E, or F?
I'm talking about, is T and then the range, and the 3 has a bracket on it instead of parentheses. Or is it just 0 is always the one that?
No, it's this, okay, so God, I've said this like 10 times. All right, this, a point when you change is a neither point. It's not increasing there, it's not decreasing there, nothing happens. Don't include it.
So how can we put a bracket there then?
On what?
3 on the range E?
Oh.
E?
The question is asking something different. This is asking for which x's is this function decreasing? This is asking what are all the possible x's?
Oh, okay.
They're not related. I mean, they're somewhat related, but they're not really related. It's a completely different question. They're totally separate. So this is asking when is it decreasing? At that point, it's neither increasing nor decreasing.
Oh, I
It's a
see.
pause, and so at that x is when it starts to decrease just after it, up until 4. But this is just saying what are the possible x's for G? And those possible x's range from this x over to that x. Yep. So 2 separate questions. Okay, all right, so sketch the slope intercepts of the following linear functions and then sketch the graph. So this should be really easy for you guys. This really was the last chapter as well. Where does this thing start? -3. And then what happens? Go over 1 up 3, yep, or rise 3, run 1, anyhow.
That makes the x-intercept 1.
It does make the x-intercept 1, exactly. Yep, your y-intercept is the point 0, -3, right? Your x-intercept is the point 1, 0. Where is this function increasing? -infinity to infinity. It's always increasing, right? Never decreasing. Okay, how about this one? Where does it start? 4. Goes down to over 3. Okay, what is the y-intercept as an ordered pair? Uh-huh. What is the x-intercept as an ordered pair?
6, 0.
6, 0. And is this where is this function decreasing?
Decreasing
Infinity to infinity, always. Or you could say all real numbers, right? It's always decreasing. Okay, example 6. This is a tricky way of giving you ordered pairs. A little bit tricky. So find a linear function that satisfies f of -3 equals -2 and f of 5 equals 4. So the number inside the f, is that the x or is that the y? That's the x. So you have one point that is -3, -2, another point that is
5, 4.
5, 4. And so if you have 2 points and it says it's linear, that means that you have a slope and an intercept, right? So first find the slope. What is the formula for slope?
Changing y over change of x.
So y2 minus y1 over x2 minus x1 is going to be what? 4 minus negative 2 over 5 minus negative 3. So what's that, 6 over 8? Does that reduce?
Yes.
Yes, 3/4. And you really need to practice using slope. You need to practice using point slope form if you don't like it, because you're going to see it next semester, and so you need to be prepared. So that is this y minus y1 equals m times x minus x1 form, which just comes from the slope equation, right? It's nothing different. It's just like you move the x2, x1 over to the other side. All right, so put in a point for x1, y1. Let's just do, which one do you want to do, the 3, 2?
Yeah.
Sure. So that will become y plus 2 equals, what goes in for m? 3/4 x plus 3. Technically, I didn't say to solve for y, so you could stop there, but let's do it just to make sure that we can. Y plus 2 equals 3/4 x plus, what's 3/4 times 3? 9/4. And then you're going to take away 2. So what are you going to need to, what do you need to take away 2 from 9/4? Common denominator, so that's the same thing as 8/4, so 1/4. Alrighty. So the next thing that we have is something called a piecewise function. So this function is composed of 2 lines, and you use one line if x is less than 0, and a different line if x is bigger than 0. So this is for all the negative x's. Does that make sense? And this is for all the positive x's.
So 0 is considered negative.
In this case, 0 goes into the negative box, although it technically can go in the other box and the picture is the same. So here's how I would suggest starting to graph it. Take this boundary point, in this case this is x equals 0, and plug it into your function. Does that make sense? So 0 gets plugged into, like if I said find f of 0, does it get plugged into the first thing or the second thing? The first thing. That's negative 0. So what point do you have? You've got the point 0, 0. And because there's this or equal to there, that point is filled in, right? Does that make sense? Okay. Now you have a line with y-intercept 0 and slope negative 1. If x is less than 0, where do the x's that are less than 0 live? Do they live on the left side of the y-axis or live on the right side of the y-axis? They live on the left, right? So draw that line, but only go backwards. Does that make sense? So instead of going down 1 and forwards 1, that's not where that line lives, right? It lives up and back 1. So that line lives over there. And do the same thing here with the second thing. If you plug in 0, technically you don't plug 0 into that part of the function, but you'd get an open circle then. It tells you where to put your open circle. And then what is the slope from that point on?
Is the slope from that negative?
Yes. And if the slope is negative 1, it's either negative 1 over 1 or 1 over negative 1. So if you go up, you go backwards. Yep. All right, what does the x thing look like then? Up 1 over 1. Anybody recognize that picture? Yeah, it's an absolute value. It's composed of 2 lines, one that has slope negative 1, one that has slope positive 1. Okay. So that one was broken at 0, 2.
No.
You're okay? All right, next one, where is it broken at? Sorry, Charles. Okay, this one's broken at 2. So start by plugging in 2 and figuring out where you're going to start. So f of 2 will equal what? 4 minus 3 or 1. So you've got the point 2 comma 1. So over 2 up 1, and that's filled in because this says that x can be equal to 2. And then do you graph the line to the right or to the left of that point? So this says that you use this line if x is bigger than 2 only, right? So do the bigger than 2's live to the right of that dot or to the left of that dot? To the right. So from that point you graph, you go up, how many? 2 and over 1, because you can just use the slope. Up 2, over 1.
So wait, how do you know the slope? Okay.
It's the number in front of the x. It's just that you don't start at the y-intercept, you start at the point x equals 2. All right, what will negative 5 look like? That's definitely y equals negative 5. It's a flat line. So 1, 2, 3, 4, 5. Okay. Yeah, there's an open circle at 2. Why can't the line extend past that open circle? Would your function be a function anymore? No, exactly. So those two pieces didn't glue together. Okay, how about this next crazy? This next crazy one is 3 pieces, right? Wow, I know. I meant to change this so that it was nicer, so I changed it on my notes. Take this thing, instead of making it negative 1/3, make it negative 3. Otherwise, you had to begin at a fractional point. So I meant to change that, and I don't know if I fixed it on your notes. I probably did. I did? Okay, I just forgot to fix it here. Okay. So start by plugging in negative 1. When you plug in negative 1, you get positive 3 minus 3 equals 0. So you've got the point negative 1, 0. Okay, it's filled in. And from that point, you could go down 3 and forwards 1, right? Or you could go up 3 and backwards 1. Which half do you want? Up and up and left. Because those are the points where the x's are less than negative 1. Okay, what happens in the middle between negative 1 and 3? What does your function do? Increase, decrease, constant. Constant. There'll be an open circle to start. And how about when you end? Is there an open or closed circle? Open as well. Okay, that's the middle part. And then the last part. So plug in x equals 3 to figure out where you start. That'll be 15 minus 17, right? Which is negative 2. So you plot the point over 3 down 2. Do you end up filling in that circle?
Yeah.
Yes, you do. Okay, so fill in the circle. And then from there, what's your slope? 5. So up 5, 1, 2, 3, 4, 5, over 1. Zoom tight. Awesome. Okay. So given that information, assuming that that was actually negative 3 and not 1/3, what is f of negative 4? Which part of the function would you plug negative 4 into? First, second, or third? First. So that would be negative 3 times negative 4 minus 3, which is 12. F of negative 4 will equal 9. f of -1, which part does -1 get plugged into? First, second, or third? First. So that'd be 3 minus 3 or 0, right? How about f of 3? What does that get plugged into? First, second, or third? Third. We already did that one, didn't we? 15 minus 17 will give us -2. And then finally, how about f of 4? What does that get plugged into? Third, greater than 3, yep. So it'll be 20 minus 17 or 3. What if I'd given you f of 0? What would that equal? -2. Technically, you plug it into this, but there's nowhere to plug it into, right? So that says the y is always -2 no matter what. Okay. Find the domain, range, and intervals where f is increasing, decreasing, or constant. So look at your picture. I think the domain is all real numbers. Do you guys agree with that? Okay, so -infinity to infinity or the little r symbol, whatever you like better. Now the range, what is the lowest y that happens?
-2.
And it happens a whole bunch, right? So -2. Does that gap that we have there matter?
No.
No, because it's filled in by the other side, so it's just -2 up to infinity. Okay, where is your function decreasing? -1. And God, I hate this technicality. I mean, like, I never want to include those endpoints, but until I can, like, check and see what Alex is testing you on, like, either one's okay. Okay, it's just not worth worrying about it because it's just semantics. There's a rule and I'm just not sure what they want from you. How about where is it decrease? So where is it increasing? When does it start increasing? I think it starts increasing at 3. Because when it's looking for these intervals, they're looking for x values. You just gave me the y. Yep. So it's either it's either 3 to infinity / parenthesis 3 to infinity. And I think which one you give depends on the semantics of your book. So just for now, your book definitely was giving square brackets. And then where is it constant? Yep. 2, 3. And I can't tell what they want for endpoints, so I'll come back tomorrow with a better answer for those questions because it's not clear. The constant thing, the endpoint thing?
I just wanna look at the graph.
Yep. Okay, how about -0.9? What's that going to round down to?
0.
-1.
Oh, yeah.
Think about your thermometer rounds down to the nearest whole degree. And 0.1 is going to round down to 0. All right, and here's what the picture of that thing looks like. To get a finer pen so I can draw well. So if you were to plug in 0, 0 would remain at 0, right? And everything up until 1 will round down to 0, right? Does that make sense? Like 0.5, 0.7. But once you hit 1, what happens?
Open circle.
Open circle and jumps up
2 and 1.
to 1. Does that make sense? And then from 1 to 2, up until you hit 2, everything rounds down to 1. Looks like that. You kind of get this steppy picture. And it keeps going forever and ever and ever, right?
Yeah.
And the pattern also continues in the negatives. All the numbers like -0.1, -0.5, those run down to -1. And then -1 also rounds down to -1. So those little dots just mean the picture continues in both directions. Okay, that's what that crazy function does. That's it for today. We'll do taxes later.